Welcome back to the YouTube channel, everybody. Today we are going to be looking at Chapter 8, Section 5, and we will be discussing a pretty common application of some of the trigonometric ideas that we've been discussing. However, before we jump in, I do want to remind you to go ahead and take just a moment to smash that like button, subscribe to the channel, and be sure to ring that bell if you want notified anytime that I upload new content. Special shout out to Mrs. Holloway, my only Patreon viewer. So back at it. Just as a reminder, in these videos we are going to be looking at the content in this video, and then at the end what I'll do is I will go ahead and provide and write out a few examples that if you have them prepared by the time you come to class on our next class, it would save a ton of time. All right, anyway, here we go. We are going to be discussing Chapter 8, Section 5, and I'm going to name this slightly different than it is in our text, but we're going to say applying trig. Now, this could possibly be the name for a ton of different sections that you're going to encounter, in your future math careers. So I'm just going to highlight here that this is, in fact, an intro video to this, the first little place that we see it. So the main topic within here is simply going to be some definition stuff. So we're going to be looking at very specific angles. Now, both of these are going to get vocab, but instead of a formal definition like we typically do, a picture, I'm certain, will be sufficient or will suffice for our purposes here. So we're going to look at angles of two different flavors. First of these is going to be angles of elevation. And the second part, and depression. Now, just as a full disclosure, when we talk about depression in mathematics, we are not approaching this from the viewpoint of, mental well-being. When we look at these, they mean very specific ideas that we're going to use to make triangles, hence the trigonometric part, to solve problems. So the easiest way to look at these is typically you want to have it from a person. Here we go. Let's say we have a person standing right here. We're going to actually have two people. So let's say we have a person standing on the ground, and they're going to be looking at somebody who's on top of a cliff over here, or a mountain, something of the sort. Now, if we have two people, we're going to have two different angles that we're going to be able to encounter. The first person, here they are, they're looking up. So we have two people standing here. Two people. Now, when we talk about these, there's always a part that people get goofed up on, but here's all I'm going to do. I'll use two different colors. I'm going to pretend that I have a line of sight here, and we're just going to make eye contact. So we'll go ahead and we'll make eye contact here. They're looking, gazing into each other's eyes. Now, what's challenging and what can be challenging about this is we always want to make sure the following happens. Before we draw anything else, I'm going to make a really important comment down below. We always measure in a one particular direction or from one particular place. We always, super duper important that always, measure these angles. These angles rather. Always, always, always measure these angles from the horizontal. Okay. Always, always, always. Now, this statement can be kind of unclear depending on how you're thinking of it. When I'm referring to the horizontal, this person's horizontal on the bottom is different than this person's horizontal up here. I'm going to sketch from their line of sight a line that is horizontal, a sideways line. Now, I'm going to extend that out a little bit further, very intentionally. We have this horizontal. This person, their horizontal is different in a different location, but it's parallel. We have two horizontal lines here. Horizontal, I'm just going to say H, we'll just write it, horizontal. Up top from that higher up person, and we have a horizontal down here from the lower person. Now, in drawing this horizontal, what it allows us to do is a couple things. First off is if they are indeed horizontal, then those must be parallel, which all of a sudden means that we have two different angles being formed by our line of sight, this blue one, that are cutting two different parallel lines. This is just a transversal. Now, commonly what we'll see, and I guarantee we'll do this, is it's pretty typical to add a dashed vertical line onto this. The reason we add this dashed vertical line is we now get these two beautiful right triangles that we can deal with. Okay, if you remember from the horizontal and that we have vertical lines that make our right triangles, these problems, they're going to come in story flavor, like they're going to give us a context and a situation to look at. It's no different than the trig we've been doing, other than we now have a context. Okay, the two words that show up here that we need to be able to keep track or keep straight in our heads. First one, this person down here is looking up. So I'm just going to put it right here. They look up. And I'm going to say specifically they look upward. That means that this angle, which we can call theta, this angle, theta, is an angle of elevation. Angle of elevation. They are elevating their line of sight, just like an elevator moves you upward. They are elevating their sight. We get an angle of elevation, and I wrote elevating incorrectly. Here's your angle of elevation. Okay, similar kind of logic working out here. This person is looking downward, which is where that emotional state of depressed comes from, or the physical state, slowed down, decreased, made to go downward. This person looks downward, which in the world of mathematics, we would say that this angle that gets formed, theta, because it's going to be the same angle, we have parallel lines cut by transversal, is instead, right here, our angle of depression. Angle of depression. Okay, we get those. That is the main idea within this section. Now, the rest of the time that we're going to deal, and this is super quick video here, I'm going to use a little editing magic. I'm going to pause this while I jot down the example problems I would like us to work in class. What I would like you to do is, if you have any questions with anything that's been said thus far, if you're taking this in your notes, pretty good chance that you have a line running down the side of your notes that produces a margin on your page. Please make down any notes or comments that you have questions from anything discussed here on the side so you don't forget them by the time we're in class together. All right, so from here then, I'm going to pause this and you are going to see a few different example problems in 3, 2, 1. So here's our first problem. We have an archer that's aiming at an apple 12 feet above the ground. We are holding the bow 4 feet above the ground because, you know, we're people and we have height. We're looking for the angle of elevation theta that we should shoot this arrow at. Now, I didn't write it out, but I want you to be clear. We are going to work this one with the assumption that this is going to be shot straight. We're not going to deal with the curved path that this could follow. Okay, so go ahead, pause the video now, write this one down, leave some space here. Do not write this statement. Just make sure you leave some space so we can draw the picture and solve it. And you will see another problem show up in 3, 2, 1. So here is our second problem. A lifeguard watching a beach from the chair, like the big fancy lifeguard chairs, and in their line of sight that is 6 foot above the ground, they look out to the sea and they notice that somebody is swimming in the water, and for whatever reason, they know that they're looking at an 8-degree angle. Our job is going to be to determine how far from the lifeguard is the swimmer. Now, when we say how far from the lifeguard is the swimmer, we'll have to clarify because there's a couple of different answers that might make sense based on the picture that we draw and what we agree on in class. All right, so pause the video now. Let's get one more problem in here, and it's actually going to be a different example name, but pause it now, and you'll see the last problem that we're going to work in class in 3, 2, 1. And here is the last problem, and I know it's wordy, but we have two buildings that are being sighted, which just means a camera is pointed at a specific location on the buildings. we'll see later in the problem that it's actually just going to be pointed at the base of these buildings along the ground. But we're sighting these from the top of a 200-meter tall skyscraper. We have one building called Building A that we sight in at a 35-degree angle of depression. We have another building, Building B, which is sighted in at 36 degrees. We are trying to find the horizontal distance between these 2 points at the base of each building, as long as we are working with the assumption that they are at the base. We're looking for the horizontal distance. This problem, when we encounter it, is going to require a little bit more drawing than the other ones, to make sure you leave space. But that is all that I have for this video. I believe that I have a worksheet in class, but if that is not the case, I will make sure to update the Google Classroom. As always, appreciate you guys. Hopefully you found this video helpful, and please do not hesitate to give me feedback if there's something you love or hate about this video. All right, later Raiders.